Hey mathlets, have you ever checked your IB exam mark scheme and seen a little A1 next to an answer? That A stands for accuracy mark. It means your answer isn't just right, but it also got the right amount of precision. It sounds a bit confusing to you, isn't it? Imagine this. You've just finished a study session. You're feeling good, and now it's practice time. You start answering questions, and boom, you see instructions like write your answer correct to two decimal places, or for significant figures, or even worse, nothing at all. So, what do you do then? Just guess? Round however you like? Nope. Here's the golden rule for your IB exams. Always keep your answer exact or round it to three significant figures, unless otherwise instructed. This is super important to get those accuracy marks. And to be honest, we've seen lots of students lose those marks just because they don't follow our instructions. Welcome to Learn Math by Example at Sam's Hub. My name is Sam, and my goal is to make math clear, simple, and even fun. Today, we're diving deep into the truth about accuracy. So, in this video, we'll cover everything you need to feel super confident with accuracy in math, science, and especially your IB exams. We're going to check out why we measure things, what accurate really means for numbers, a quick look at decimal places, making sense of significant figures, how to round numbers the right way every time, and finally, a short quiz to see what you've learned. Before we talk about accuracy, let me ask you this. Why do we even measure stuff? It might seem obvious, but think about your IB internal assessment, your IAs. Let's say you want to write an exploration to compare the effect of applying a liquid fertilizer to a plant, let's say tomato, in two different scenarios. In the first scenario, you pick a dosage, let's say 10 milliliter, you mix it with water, and then you water the plant every week with the same dosage. In the second scenario, you do exactly the same steps as in the first scenario, but this time you're gonna increase the dosage every week by 1 milliliter before you water the plant. Each week, you monitor the growth of each plant and write down the information you got. This means we measure to get good, trustworthy information. Whether you're comparing data for your math IA, or you're timing a pendulum swing for your physics IA, or carefully weighing chemicals for your chemistry IA, measuring is how we collect data to figure out how the world works. And the better our measurements, the more accurate our results will be. Now that we know why we measure, it's time to revisit decimal places and significant figures before moving on to accuracy. First up, a quick review of decimal places. Remember, this is all about how many digits are after the decimal point. We just count them, simple as that. Now, the first step is always to find the decimal point and then look at the digits after it. So in a number like 3.1415, the first digit after the decimal point is 1. That's the first decimal place. The next one is 4. That's the second decimal place, and so on. You just count them up, nice and easy. Here's a quick heads up. Now if you have a number like 12.50, the final zero actually counts as a decimal place. It tells you the measurement was precise enough to know that digit was a zero, not something else. So 12.50 has two decimal places. Here's another interesting example. 0.7, which has one decimal place, and 0.700, which has three decimal places. Although they have the same value, they have different decimal places. It's simple, right? Decimal places just tell us how many spots are filled after that little dot. Super helpful when you need exactness. Following this, how many decimal places do you think 25 have? You've got 5 seconds to think about it. It doesn't have any decimal places. Remember, decimal places are all about how many digits are after the decimal point. Since we don't have a decimal point here, so there are no decimal places. Next up, let's dive into significant figures, or sig figs for short. These are the digits in a number that actually matter for its precision. They tell you how much we really know about that measurement. First rule: any digit that isn't a zero is always significant. So in a number like 234, all three digits, 2, 3, and 4, are significant. Second, zeros that are sandwiched between other non-zero digits are always significant. Think of 1005. The zeros in the middle count. The number has 4 significant figures. Third, zeros at the beginning of a number, we call them the leading zeros, are never significant. They are just placeholder. For example, 0.0078, only the 7 and 8 are significant. It has 2 significant figures. Finally, zeros at the end of a number, we call them trailing zeros, are a bit trickier. Now, if there is a decimal point anywhere in the number, those trailing zeros do count. Like in 12.00, that's 4 significant figures. But if there's no decimal point, like in 5000, those trailing zeros usually don't count. So 5000 just have one significant figure, the 5. Well, it's time for a little quiz in significant figures. I'm just going to ask you one question. How many significant figures do you see in each number? Got it now? Significant figures help us understand the actual precision of a number. That's super important for scientific calculations. Okay, with decimal places and significant figures fresh in our minds, let's talk about accuracy. Basically, a number is more accurate if it gives us more exact information. And how do we see that extra detail? Usually, it's by looking at how many significant figures or decimal places it has. Ben says he's 1.7 meters tall. Okay, but Adam says he's 1.732 meters tall. Now, which one sounds more exact? You've got 5 seconds to think about it. Adam is more accurate, right? Now, because 1.732 meters shows more specific digits, it means they measured with a finer tool. For things like building houses or making clothes, that level of detail is a big deal. Okay, you've learned about decimal places and significant figures. Now, let's put it all together with rounding. This is how you make your numbers neat and tidy to the right level of accuracy. Step 1. First, figure out which digit you need to round to. Let's call it the target digit. If we're rounding 5.738 to 2 decimal places, we look at the second digit after the decimal point, which is 3. So 3 is the target digit. In step 2, you look at the digit immediately to its right. In our example, that would be 8. Let's call it the decision digit. In step 3, here's the rule. If that decision digit is 5 or higher, you round up your target digit. If it's 4 or lower, you round down, which means just keep the target digit the same. So since our 8 is 5 or more, we round up the 3 to a 4. So 5.738 rounded to decimal places becomes 5.74. Now, have a look at the following examples. Now for significant figures, the same idea works for it. Let's round 245,678 to three significant figures. So we look at the first three important digits, 2, 4, and 5. The digit after the 5 is a 6. Since 6 is 5 or more, we round up the 5 to a 6. And remember, when rounding whole numbers, you need to fill in the rest of the places with zeros so the number keeps its size. So 245,678 rounded to three significant figures is 246 thousandths. Now let's look at the rest of the examples. So in conclusion, rounding helps us give answers with the right amount of precision, making them clear and useful. Alright, it's quiz time. Let's see how much you've got this. I'll show you a question and you'll have 10 seconds to think. Feel free to hit pause if you need more time. Let's do it. Now, by mastering decimal places, significant figures, and rounding, you're not just getting better at math, you're learning a super important skill for science, engineering, and just life in general. Understanding accuracy will totally boost your IB exam scores, especially for those A1 marks. Now, here's one last challenge for you to think about before we wrap up. Imagine you're baking and measuring ingredients. Why is being accurate important there? And how would you describe the accuracy of 2 cups versus 2.125 cups? Write your answer in the comment below and I'll make sure to check it for you. If you still have questions or need more help with any of this, just drop a comment below. I'm here to help. And hey, if you ever need a hand with your math homework or support with your math IA, be sure to visit our website and check our services. The link is in the description below. You'll definitely find more exercises to practice and be sure that you totally understood the lesson. Don't forget to like this video, subscribe to our channel for more great math content, and hit that notification bell so you do not miss our next lesson. Keep learning, keep exploring, and I'll see you next time.